So this is going to be the end result we're making in this video. An omnidirectional attack and dash that has some polish to it and is not too hard to implement. Alright, so I just want to do some cleanup from last time, and if we go on our game, you can see that our dust is about as visible as our player, and while it's not really the best, it feels like it isn't dust considering the size of it, and when we jump we're not really going that high in comparison to how fast we can walk across the screen. So what we're going to do is, first of all, we can open our scene under effects, jump land dust, as well as open our walking dust, and we're going to change the modulate to 50 on the alpha on both of them, and you can change this to what value you want, but with 50 it becomes a fairly subtle effect to notice, but it still feels like they're kicking something out as they're moving forward, so they feel like they're propelling themselves, and you still get that land and jump thing that responds to the player's movement. And then if we go to the player, we're going to increase our jump power to 1200, and that really just makes us jump really high, and it feels pretty nice. So I'm also going to go into project settings, and on input map, I'm going to add an action called attack. I'm going to add, look at this plus button, add a mouse button this time, and we're going to use device 0, which will basically just be the first mouse you've plugged in, and left button, which will be our left mouse button. And we don't have anything to respond to this yet, but that's okay. Also going to go into project settings, general, and scroll down to the layer names, and we want attack to be our 4th layer on both of these. Then I've also updated our player body as well as our attack. I think this is the new melee attack. I can't remember whether I've imported it. Yeah, so I've already got the new one imported. Then pretty sure this is the new player body. This actually isn't. Quickly delete this. Oh, I don't know what I did there. Delete assets. Drag in my body. And we just re-import that. And the new body, it has a different H frames and V frames. We're just gonna reset these and count them again. So we got 1, 2, 3, 4, 5, 6, 7, 8 this time on the H frames, and 1, 2, 3, 4, 5, 6, 7 on the V frames. So if you had, if you were watching this series before this video came out, then the GitHub would be unupdated to these new things we have. You can just go to the GitHub and re-download them. And if you're not, well, it's not a problem for you. And yeah, you don't have to change anything with the animation for player. The frames I added were at the end, so that way, as we scroll up, we don't have to reset all of these. If I had put them at the start of our spreadsheet, then we would have had to redone everything, which, well, you know, don't want to do that. So something else we're going to do with the player is just change them to be a bit more of a grey color. So we can set these to all like, let's say 60 for now. Let's just up the frame around so we can get a better look at that. I think that's pretty good. It kind of blends with our background right now as we make more of the game though, and you know, backgrounds, then it will become less visible. So then, now what we're going to do is we're going to create a new scene by clicking this plus button next to our player. It's going to be a 2D scene, and we're going to name it Sludge Melee. So we're moving on to the player's attack, and the reason we're naming this Sludge Melee rather than player attack is because we might actually have multiple things use this. So like the player and also other enemies might use it as their attack. So then we can save it. I'm going to save it under attacks. I'm going to add some nodes to it. We're going to sprite. I'm going to add an animation player. I'm going to add an area, 2D, and we're going to add a collision shape 2D to that area. So then, now we're going to rename this area hood box, and we're going to assign its collision over here. We're going to move it from this layer and mask. On the layer, if you click these three dots, then you can see their names. Also, if you were to hover over stuff, then well, you can see it as well. So layer, we're going to put it to attack, and the mask, we are going to have to detect the player and the enemy because it will be used to hurt both of them. And then we're going to have connect the body entered signal. Just going to double click that. Oh wait, we haven't made a script yet. So we gotta attach a script to this Sludge Melee. Now we can connect that body entered. We can delete all this stuff up here, keep this though, create some space, save that. Now we're going to go back and continue setting up these other nodes though. So we go to inspector and drag this melee into our sprite's texture. Just going to scroll out. And we've got 1, 2, 3, 4, 1, 2, 3, 4. So 4 V-frames and 4 H-frames. And we're just going to move this down by 2, the Sludge Melee, so its position will be 2 on Y. And then now what we can do is go into our animation player, new animation, and name this attack. Then what we're going to do is we're going to change the snap to 0.2 seconds. And then we will key in this frame 0, scroll it to 0.2, go up a frame, then key it, key it, key it again, key it again, and once you make it to 1 second, you can key it one more time. Sorry, I was just doing wrong frame. So this frame needs to be of a value of 5, and actually I forgot, we're actually going to have this snap value of 0.02, so then we can drag these way close to each other. Just kind of make sure that this last little square thing looks empty, and you'll have them at the right positions. Then we can zoom in, so they're all 0.02 seconds apart. So it takes 0.1 seconds to get the attack to its maximum size. So then that way we've got very little input delay for the player. But then we're going to up our snap a bit, because we want there to be a longer recoil for the attack than wind up, because that way it'll feel heavier and stronger. And we're not going to go too overboard because we have such a quick response time, and our attack just is kind of like a mini slash, so we don't want to make it look unrealistically long. But if we even just by changing it a bit, we'll make it slightly more satisfying. So if we scroll to where we are next here, click on our sprite, up the frame, and just key it until you get the frame 13, which you don't need to key. and change the duration to 0.3 seconds. So take 0.3 seconds to attack. The very short and quick attack. And now we are going to add in the amount of time it takes for the attack. So go to our collision shape 2D, and we're going to have it at 0.05 seconds. It's disabled, so we'll keep that. Then the next frame, 0.075, will be enabled, and it'll stay enabled until maybe just before 0.2, and then at 0.2 we'll disable it again. And then lastly, we are going to add a call method track connected to our large melee, the root node, and at the end we're going to insert a key, Q3, so it deletes itself once it's done. And don't put this to autoplay, because we're going to do some calculation in the script before we actually play the attack. So now we're going to create a variable for our damage is equal to 0, var its player is equal to false. Already var sprite is equal to money sprite. Already var animation player is equal to money animation player. Then we're going to go down, create a new function called creation. So we will call this whenever something wants to create it. And then what we're going to do is we're going to add some values that will be passed to it. So we're going to have isPlayers. So that way we know if the attack is trying to harm the player or it's trying to harm the enemies. And have the color of the attack. That way we can differentiate between the player's attack and the enemy attacks. And we might be able to have enemies with different colored attacks to give them a bit more unique attack. And that's why I did it pure white. That way we can just modulate it any color we want. I'm going to do direction. This will be to just, if we end up, since this is going to be Omni Directional, we're going to have it that it can be rotated around the player, but based on which direction it's going to be attacking, we want it to still look like it's attacking the same way rather than just rotated. So we're just going to use that for a very small touch, which I'll talk about when I actually get there. We have the damage amount. So that's the amount of damage this is going to be doing. So now we'll do damage is equal to damage amount, and hurts player is players. We should change this around to hurts enemies. So then, if isPlayers is equal to true, then hurt enemies will be equal to true. If isPlayers is equal to false, then hurt enemies will be equal to false. Then we can just create another line. If color is equal to string black, then we want sprite modulate is equal to, then we want 6 zeros, because that's the color of pure black. Then elif color is equal to white, sprite dot modulate is equal to 6 f's. because that's the color of pure white. And we might change these colors around later. It's just some starter stuff though. And if direction is equal to left, then straight.flip v is equal to true. And the v is important because when we rotate our if we rotate this, so I'm going to transform 180 degrees, so it's going the opposite way. We want it to finish the same way it started. So if we play this at 0 rotation degrees, it starts at the top here and ends at the bottom here. So, but when we rotate that 180 degrees, it starts at the bottom and finishes at the top. So rather than flipping the H, which is an offset, which would just change which way it's looking, we're changing the V so that way it starts at the top, finishes at the bottom. Just going to reset these. Okay, now we're going to go into our script, and in the hurt box body entered, we want to check if hurts enemies is equal to false, and body is in group player, or hurts player is equal to, hurts enemies is equal to true, and body dot is in group enemy. We want the body to call the function receive damage type, and we're actually gonna add another value up here, damage call it type of damage. That way you can go for damage type is equal to nothing as a string right now though, and then damage type is equal to type of damage. So then we can pass in a type of damage like physical, electrical, fire to this melee, and then depending on the damage type we might add some effects to it as well to make it look more unique, or like that damage effect would look like. So when it hits something, if it isn't meant to hurt enemies, then it would be meant to hurt the player. So we check if we're hitting the player, and if so, then this little line becomes true when you do body.receive damage. Otherwise, if it hurts enemies and the body is in the enemy group, so it's an enemy, then it is also going to be true. I'm going to call this function. So the actual attack isn't damaging the enemy or player. It's just going to call the enemy or player to receive the damage, and it gives it the damage and the damage type. That way, if we want to give them any resistances, we can have in the enemies or player's code that they are going to resist this type of damage, or maybe vulnerabilities as well. Then they can maybe be more vulnerable to different types of damage. So then just some last touches on what we need this to be. We go to about where it's largest, then our collision shape. We go new circle, and we're going to set the radius to 9. And this will be for the player, because then, because we want to give the player a bit of extra room for if they hit the enemies, because if we make this any smaller, then we've got a fair amount of space would the effect could be overlapping individuals, but the actual simulation won't hit the enemies, and even though visually it's hitting the enemies, the game will say that the player isn't, and the player will believe that's unfair. So it's okay if we make it that it goes out of the range a bit for when the player is attacking, because, well, if they don't quite visually hit the enemies, but the enemy's taking damage anyway, the player doesn't really care. They're just happy that they're hitting the enemy. But if they are clearly hitting the enemy and the enemy doesn't take damage, it's gonna upset them, of course. But since this is going to be used by the enemy as well as the player, I'm going to go into our script, and if hurts enemies is equal to false, we got money collision shape 2D dot I think we go dot shape dot radius, right? Let me just check this. Yeah, radius is equal to 8. So that way it'll be one smaller. There's still a bit of a gap, but this is going to be the front part of it, and it's going to be where most is happening. And if it ends up becoming a problem, you can always readjust this value. So right now I'm just going to create a ready function. Creation. False, white, it's gonna do E, damage amount 5, type of damage, don't need it to be specific at all. I'm really just testing that this works, because I can't remember if this is the code that we do. It didn't crash, so it did work. We can delete this. Then at the end here, I'm just gonna go animation player dot play attack. And now we're done with this large melee, so we'll move over to the player. And in their script, we're gonna add a new state, dashing, not attacking, and then we're gonna go down and add base. Then we're also going to declare a new constant, so const large melee, the preload large melee.tscn, tscn again important. Then we're gonna create a new variable underneath our state called attack mode, and set that equal to base. So our different attacks, we're going to put just the space between them, and our different states for the player that we're going to have up here. So then we'll move down to our state, and we'll go var attack mode is equal to base. I'm just going to undo that breakpoint I somehow accidentally added it in. And then what we're going to do is we're going to head down, we'll go into physics process, underneath basic, I'm going to call check for attack. And that's not a function yet. I'm just going to actually move this animate underneath the physics process. I'll put everything that needs to be called all the time in a group, and then everything that's just part of the base function we'll put in here. So then we'll create our check for attack function, and in it we're going to check for if input.is action just pressed attack colon match attack mode base. So that way in the future, when we make more different types of attacks, we'll just go off of that. So then if base, no wait, actually we gotta make some timers. So we'll go in here, add a new timer node, base attack time, set it to 1 shot and have a duration of 0.5 seconds. So then we gotta declare it as well, sorry. Onready var base attack time is equal to money base attack time. So then now we can do if base attack time dot is start, then base attack time dot start. So that way we've got an attack cooldown, as well as like we're making sure, since this lasts 0.3 seconds, we're waiting for it to finish and then giving it a 0.2 second after delay of where we can't use it. Might change that to be a bit shorter, might change it to be a bit longer. We'll adjust it more when we get onto making enemies and balancing out the combat. So then, now what we're gonna do is go var large melee is equal to large melee dot instance self dot add child. Rather than getting the parent, we're using our self, because if the player moves while they're attacking, we don't want their attack to stay where they were, we want it to move with them. So we're adding the child large melee. Then we're going to create a temporary variable with our mouse pose is equal to get local mouse position, which will get the mouse position relative to where our player is positioned. Then we go dot normalized, which basically uses some math to make it so that the value of our mouse position will be between -1 and 1. And since our mouse position will be a vector 2, it'll apply that to both vectors. So our x and y will be between -1 and 1, which makes it an easy number to do some other math with, multiplication and stuff. So now we're going to do large melee dot position is plus equals actually mouse pose times 7. So that way it gets offsetted in a direction to the player. And then we'll do large melee dot rotation, and we're using rotation, not rotation degrees, because rotation deals with radians rather than degrees. The reason we're using radians is because we're going to be calling a function get local mouse position again, but then this time we're doing angle, so that'll get the angle between our player and the local mouse position. However, the angle method returns the value in radians, so it's easier just to, rather than converting this into degrees, which is also really easy, but it's easiest to just use rotation and just get the angle without converting it. So then we go var direction is equal to pass for now, that way it has a value. Then if large melee dot position dot x is bigger than 0, so that way if it's to the right of us, then we want our direction to be equal to right. Elif large melee dot position dot x is smaller than 0, then we want it to be to the left. We got one more line. Large melee. Oh, I forgot to put the equal in there. So large melee dot creation, and we're going to set it to true because the first value we're passing into it is whether it's created by the player or not. So true. I'm going to make it black, and we're gonna add our direction. Then we're gonna insert 5 as our damage number for now, and we'll go physical for the damage type. So then we launch the game, and if we attack, we've got this black slash that will go in whatever direction our mouse is relative to the player, which at the moment it's a little weird to get precise because our player moves around the screen and we gotta adjust for that. But once we set up our player's camera properly, the player will be in the center of the screen, like practically all the time. So then it'll be a lot easier to aim our attack. So now we're just gonna set up effects for when we do the dash, and I'm just gonna create a new scene, other node, and we're gonna use a sprite as our base node for this. And we're just gonna add an animation player. And then we're gonna not assign a texture to the sprite, actually. We'll handle that with code, and you'll see what I mean later. However, we are going to modulate it just so that way it gets a specific color. So we modulate it to the color that I have chosen is 96, 44, 39, 49, and it's a darker purple, so that way it'll look a bit ghostier, and we're going to name this effect our ghost trail. And we're gonna go into our animation player, new animation, just name it default, set autoplay to on, go into our ghost trail, then we're gonna go to self-modulate, key that it's fully visible, go ahead 0.1 seconds, key that is fully visible, go ahead to 0.3 seconds, and then drag the alpha all the way down to 0, and keep that, change the animation length to 0.3 seconds, add in a call method track connected to ghost trail, and insert key Q3. And now we're going to save this on the scene's effects. That's literally all we have to do for this scene. Very simple. However, the code's going to be a little more complex, just a bit more though. So we go into our player, script, and scroll up, declare some new variables. Var has dash is equal to true, var dashing forward is equal to true, var dash speed is equal to 110, var dash angle is equal to vector 2, 0, 0. So then we're going to go into our physics process, and right at the end, we're going to go, I think you accidentally deleted this line, but we want there to be an if statement, state is not equal to dashing, so if we're not dashing, then we want motion.x is equal to clamp, motion.x negative max speed, and max speed. So then I think you would have had just this line on its own, so what you could have done is just tab that forward, add in the if statement, but just make sure it looks like this at the end, this line of code right here. So now we can close that, go into our animate function, and then we're going to go add another state, dashing. I'm just going to go animation player dot play ascend. That's all we're doing. Close the animate tab. Now we're going to add stuff to our check for attack tab, and just start a new section of our code just to separate it, give it more organization. So I'm going to go if has dash is equal to true, state is equal to dashing, motion is equal to mouse pose times dash speed. And we need some more timers actually, so I'm just going to make those. Need 2 more. And go dash time. We'll drag both of these to be above our base attack time. And then we'll also do ghost trail create delay. Go one shot, we're going to set its wait time to 0.035 and set our dash time to 0.15. I think we're actually going to up our dash speed to 160. So then we need to connect both of these, set one shot true to both of them, and we're going to want both of them to be connected through the timeout signal, and we have dash time above our ghost trail create delay, and just put them under our walk dust create delay. And then we're going to scroll up, add them above our base attack time again as onReady variables. So onReady var dash time is equal to money dash time, onReady var ghost trail create delay is equal to money ghost trail create delay. So then we can go dash time dot start ghost trail create delay dot start if mouse pose dot x is bigger than 0, mask sprite dot flip h is equal to false, mask sprite body sprite dot flip h is equal to false, elif mouse pose dot x is smaller than 0, mask sprite dot flip h is equal to true, body sprite dot flip h is equal to true. So what this does is basically whatever direction we're dashing in, which is omnidirectional based on our mouse position, we're also gonna have our sprite face the correct direction that it will be traveling in. So I'm gonna go var dash dust is equal to jumpland dust dot instance. So then we're just going to be reusing this effect for our dash to add a little bit of a bonus polish to it. And we'll go get parent dot add child dash dust dot global position is equal to self dot global position dash dust dot rotation degrees is equal to rad to deg. So we're converting a radian degree value to a radian rotation value to degree rotation value. Get local mouse position dot angle, and we're going to put a minus 90 outside of this method. Then now we just go dash, no, else, what's the dash just done, motion plus equals mouse pose times 40, so we're not actually going to be dashing that far, but it'll give us a bit of a boost in the direction we're aiming our attack, so just a bit more response to it, gonna make it feel nicer. Then at the end here we'll set has dash is equal to false. So now what we're going to do is we're going to reorganize our raycast. So we're going to add a node 2D, name it raycast, drag our ground casts into our raycast, put our raycast above timer, and then we're going to add another raycast to our raycast and call this roofcast. And it will collide with the environment. I'm going to set it to enabled to negative 1.1 on the Y value, cast 2. And now we gotta update our already variables here. So we're going to go raycast slash, and then just copy and paste this line here right at the beginning of all of these. And we'll go already var roofcast equal to money roofcast. And now we'll go into our update on ground, and then if roofcast.is colliding is equal to false and state is not equal to dashing, then has dash is equal to true. So what this is doing is basically whenever we're on ground we want to make it so that we can dash again, and we're making it that we can only dash once until we hit the ground again. That way the player can't dash like upwards infinity and never hit the ground. So then the reason why we're bringing in this roofcast though is because I ran into a strange bug where whenever the player would hit the roof for a frame, these would be considered true, which normally isn't a problem because it just means that we're on the ground for a frame, which allows the player to jump while they're up against the roof, which isn't going to do anything. It's only for a frame anyway. So, and then it just resets it the next frame. And otherwise we got, but when we have the has dash in there without this, it'll make it that we can dash if we hit the roof again, which if you want that to be in there, go ahead. I'm not going to use it though because it's kind of weird, kind of buggy. So I just get this roofcast to check if we're hitting the roof. So then if we are, we're not going to set it to true. But if we're on the ground, then we are. So now we're going to go into our dash time timeout. Set our state is equal to basic. And if input.is action just pressed, right, then our mask sprite.flip h is equal to false, body sprite.flip h is equal to false, if input.is action pressed, left, then mask sprite.flip h is equal to true, and body sprite.flip h is equal to true. So what this does is just, since we override our flip h to make it the player face the direction they're dashing, this is just if they end up dashing in that direction, then they've got a keyhole held so that they will be walking in another direction at the end of the dash. That way this will reset their direction to the direction they need to be facing. Now I'm going to just close this and add our last bit of code here to get this dash fully working. So we're going to go var ghost trail, and I forgot to declare we need a new constant, and we'll add this after our dusts. We'll do const ghost trail is equal to preload ghosttrail.tscn. So then ghosttrail is equal to ghosttrail.instance get parent.addChild ghosttrail.global position is equal to self.global position ghosttrail.set texture mask sprite dot texture. So we're taking the sprite from our mask and putting it into our ghost trail. Oh, I put a comma instead of a colon there. Sorry, a period. Then we do ghost trail dot flip h is equal to mask sprite dot flip h. And then if dash time dot is stopped is equal to false ghost trail create delay dot start. And now if we run our game, we have a fully functioning dash that will go in any direction. We've got a bit of a dust from where we start off that will just really show our angle we're moving away from in our starting position. And then we've got our kind of phase effect for our skull. We're not going to use our body just because it gets a little complex. But yeah, we've got that's just to show the line we're traveling is connected to our melee. We can only do it once until we hit the ground again. And it works out pretty well. And you might want to change your own input around so that you have a different button to use this. That way the player can attack normally or dash attack. It's up to you. I've just implemented it all into one button though. I'm do some later on coding to have it work more smoothly with that one button. It's going to be designed around this. And that way we just keep the amount of buttons you need to a minimum so that there isn't as many controls to remember. Always makes the game easier. Well, not necessarily easier, but easier to understand. But then just some last finishing touches. So we're going to add another variable of our max v speed. So this is going to be actually we'll just fill this in with vertical. So max vertical speed is equal to 260 for now, and then we scroll down to our physics process and we'll do a new line motion dot y equal to clamp motion dot y max vertical speed. Did I do this negative? I didn't. That's fine. So we'll do negative max vertical speed and then max vertical speed. Maybe it isn't declared. Okay, there we go. So then this will be for when we're heading up. And when we're heading down, it's fine if gravity gets a little strong, so we'll do ×2. Then now on our dash time timeout, we're just gonna have our motion dot y divide equals by 1.25, and that's going to allow our player to not dash up so high. In fact, I might just lower our max vertical speed to 160, probably be better. No, I want them to not be able to touch that roof, so how about 140? Okay. Then I'll also increase this to 0.3. well 1.3, and there we get a decent dash effect. So it's not as strong going upwards, but that's fine, considering you can still get insane amount of height. If you combine your jump with your dash, it really just makes it quite vertical, which you're going to want to complement with vertical game design. Just an error I did is action just pressed right. You want to make sure that both of these is action pressed in order to make them work properly. So thank you for watching this video. I hope you have a good day. And if you have any questions, feel free to comment them below. I will do my best to respond. And consider liking this video or subscribing to my channel. It encourages me to make more of these videos. So if you want to see more often, then do so.